Okay, our next speaker is Brett Denevi. Is Brett on the line?
I am.
Great. And the floor is all yours.
All right, great, thank you. I want today to quickly highlight 3 themes of exciting science opportunities at the South Pole, focusing on non-volatile topics. So next slide, please. The first theme is space weathering. And as much as we know about space weathering, there are still some big questions. Probably the biggest is, what are the relative roles of the solar wind and micrometeorites in maturing the regolith? So many studies, largely from spectral reflectance data, suggest that solar wind has the bigger effect. And this is something that we can test at the poles, where there is a much lower effective flux of solar wind. So really any returned sample of typical mature regolith from a polar region will let us look at the nanophase iron and agglutinates and see how their development differs in this environment. And then even better, we should collect samples from regions where the solar wind flux differs due to local topography. Next slide, please. Even better still, there is a ray from Tycho that we can investigate. This is LOLA reflectance data from Lucy et al. And Lemelin et al. And I've tilted the moon back a bit so that we can look at the South Pole. And you can see that this ray extends from Tycho across the South Polar region. And if we zoom in a bit on the upper right here, you can see that the ray crosses next to Shackleton crater. And in fact, it goes right across the ridge between Shackleton and de Gerlache craters. So this site has been identified as a prime candidate for Artemis for a number of reasons, but I think this Tycho ray is really the cherry on top. Tycho has been dated through cosmic ray exposure ages of the light mantle and secondaries at the Apollo 17 site. And so if we collect rocks from the rims of Tycho secondaries in this polar region, we could test the age of Tycho. And further, we can have a direct comparison of highland material exposed at the same time, but at the 2 extremes of the lunar space weathering environment, the equatorial light mantle at the Apollo 17 site and the polar ray. Next slide, please. The second topic I wanted to discuss is regolith mixing and distal transport. Almost all of our sample return sites were either right at or near a Mare Highlands boundary, and Artemis samples will be from an area that is just really remote, often the Feldspathic Highlands by itself. So this is a great spot to learn about the distal transport of material by impact craters. Next slide, please. Recently, we've gotten a lot of new information that really highlights that impact craters have just extremely far-reaching effects, from impact melt found antipodal to Tycho to modeling of how rays transport material to great distances, and observations of the distal effects of new craters. So cataloging the basaltic and SPA terrain components of the regolith at the South Pole will be a great new constraint on how material is transported across the moon by craters. Next slide, please. And further, if we do indeed get the opportunity to land on or near a ray from Tycho, we can get new information on ballistic sedimentation by sampling inside and outside of this ray. And we will have a great comparison to the much older ray of Copernicus that was investigated at the Apollo 12 landing site. Next slide. Finally, the last topic, we have a great opportunity to look at the local history of the region and the depth and structure of the Highlands regolith. This can be achieved in a couple of ways. First, by coring or trenching. The Apollo cores showed that the unique impact history of a region is preserved in distinct layering in the regolith. And this is seen in differences in grain size, maturity, and composition. And coring is one way to get at this history, but trenching would be even better, so you could see some lateral variations.
Nice.
Multispectral imaging or other measurements can be used to see the subtle differences in layering and select samples to bag. And astronauts could dig trenches, but like all good geologists everywhere, we can also hopefully make opportunistic use of what infrastructure gives us. essentially studying the equivalent of road cuts from digging that's done for construction or ISRU. Slide, the last one. And core or trench samples will be even more useful if they are tied to ground penetrating radar measurements that will give you their broader stratigraphy and context. Chonga 3 and 4 GPR data have shown the detail and structure of the Mare regolith, suggesting it's deeper and accumulates more rapidly than previously thought. So comparable data for the lunar highlands will be really illuminating. And on the next slide, I will just leave you with my conclusions. Thank you.